How to perform Opensees using Etabs NonLinear Time History Analysis. Opensees is the open system for earthquake engineering simulation. Nonlinear time history analysis offers greater accuracy and less uncertainty when compared to static procedure, that is NSP. So let's start. We will use nonlinear time history analysis to perform Opensees on this simple structure. So I'll go to define. I'll define function time history. Then add new function. We use from file, add new function, browse, and local disk, program files, computer and CSI, Etabs 18, time history function. So I will use this, or you can download this online. So you can download these time history functions online based on your location. Open. You can see the function graph, then okay. Then the second, we'll add new, browse, in the second direction, open. Then if you view file, you can see Altadena Eton Park at 90 point at acceleration data equal space 0.2 seconds. So you can see the data. You can see it's 40 seconds. So click OK. Then OK. Then define mass source, modify. I will uncheck this and check specified load. Then I will use dead load and add live load. Now this time 25% of live load. So I will delete 0.25 of live load. Okay. Then I'll go to define. So now we need to assign hinges to this structure. So I'll select object type, beams, select, close, and I'll go to assign frame. I'll assign hinges, and I can just delete this. I will assign out of hinges at starting point of every beam, add. So change these to, I can use from this first table and then change to concrete beam. And then I want for flexure or moments only, then okay. Then I will add in the second point on the other end, add the same. So I can see the mode here assigned. Okay. Now we do the same for column. Select object type, column, select, then assign frame hinges, then start of each column, add. This time change to concrete column, and I prefer this degree of freedom for dead load, and then okay. Then at the other end, use a relative distance of 1, add the same type and condition. Okay. So you can see my columns have been added. Hinges have been added to my column. If we go to view 3D, you can see the hinges in my column at the start and the end of each column. Distance is 1 at the end of each column, and then the same. Okay. Now we're going to select everything and then assign frame, assign hinge overrides. Make sure auto subdivide frame object is checked. Then okay. Now you can see how it has divided the hinge at the start and the end of each column and beams. Then go to define load case data. So I will delete these load cases. We only need live and dead. And then we can add time history. So let's first do the analysis for dead and live load. So I'll go to analyze, load case to learn. I'll delete these results. Then do not run all, and then I will run. Let's first learn the linear load cases. Run now. That is the dead and live load cases. So we can unlock the model again. Now go to define load cases. And then I will add new case. Now this time is non-linear time history analysis. Then change the load case type to time history. You can change here to any, so I'll change to nonlinear model, so it doesn't matter. I will add acceleration UI. I will use the function that we imported, a scale of 0.1. Again, add for the other direction, U2. I will use this scale factor of 0.1. And then the other thing is number of cap time. We'll change it on to 1500. 0.02 seconds. And then okay. So we can go to define section, then see those, and then define section, and then we want to define, see the frame wall hinge, then show, then modify, So you can see the moment rotation data for that hinge. You can see the immediate occupancy, life safety, and collapse prevention. Then cancel. So for this beam, modify all show. You can see the hinge property data for that moment, and then the immediate occupancy, the life safety, and collapse prevention. Just click OK. Now you can go to analyze, learn do not run. So we will do not run, then I'll just run nonlinear. Let's run that, and then run. Now we can go now to display deform shapes. You can see the deform shapes. You can see the animation. Now I can go to display, spectra, curve, or let's go to hinge results. Hinge result is not responding, so just give it a couple of seconds. So I'll just save, yes. I will save it to my desktop and save. Okay, just run Etabs again, and then we're going to view those. So run Etabs 18 again. Then open this. So analyze, load case, run, did not run, then run. Then you can go to display. Change results. Change to columns. Let's go to beams. Now you can see how the hinge is moving. So this one is at the occupancy. So the hinge life safety have not been reached here. So if I go to beam, and you can be able to show report and details and be able to print these reports and details. Now I can go to display response spectrum curve or plot functions. So let's display plot functions. So you can see the plot function. You can be able to see the base fx in kilonewtons, and you can plot this summary. So this will be the end for this video. I will see you in my next video. If you like the video, please consider to subscribe to my channel.